In the first part of this video series on graphics and GUIs, we will explain how to use panels to draw graphic images. We will illustrate this technique with an example that draws a collection of rectangles and ovals. Next, we will explain what is additionally required when such panels are embedded in windows that contain other GUI components, and provide an example to illustrate this process. We begin with an explanation of the Java coordinate system and the classes and methods needed to draw graphic images. The origin of the drawing area is the upper left-hand corner of the screen. The drawing area represents one quadrant of the Cartesian plane. That quadrant is numerically like the first quadrant, but reflected across the x-axis. By that we mean that x values increase going from left to right, and y values increase going from top to bottom. The graphics class contains the methods necessary to draw geometric objects and text. Methods in this class are invoked on an object of that class. The calls to the methods in the graphics class are contained in a method that overrides the paint component method of the JPanel class. Next, let's examine a few of the commonly used methods in the graphics class. Text is drawn by the drawString method. The information that must be supplied to this method is the string to be drawn together with the coordinates of the upper left corner of the position where it should be drawn. Most geometric objects can be drawn as solid objects or hollow objects. With hollow objects, only the outline of the object is drawn. Rectangles and squares are drawn by calling the drawRect method for a hollow object or fillRect for a solid one. The parameters that are passed to both methods are the coordinates of the upper left corner and the width and height. To create a square, the width and height must of course be equal. Ovals and circles are drawn by calling drawOval for a hollow object and fillOval for a solid one. The parameters are similar to what is required for the rectangles, the coordinates of the upper left corner and the width and height. The upper left corner is the intersection of the line tangent to the top of the oval and the line tangent to the left side. A circle is generated when the width and height supplied are equal. Our first program example illustrates the use of the methods that draw strings, rectangles, and ovals, which are either solid or hollow. We begin by examining the class that performs the drawing. Notice that this class extends JPanel, which is what is required to be able to draw on a panel. It must override the paint component method that would otherwise have been inherited from JPanel. Notice also that it must be declared as a protected method. The first statement must be a call to the paint component method of the JPanel class. The graphics object that was passed to the paint component method must be passed to the method it is overriding. This step is very important. Failing to do so will leave whatever was painted on the panel still visible, which is not desirable. Next, we draw a hollow red square with its upper left corner at position 2020 and draw the label hollow red square inside it, drawn in black. Note that calling the method setColor is necessary only when we wish to change colors. Once it is set, everything that follows will be drawn in that color until it is again changed. Next, we draw a solid blue circle and inside it a white label inside it. These two statements draw a green rectangle. Notice that we have created a custom color that will be a green color of medium intensity, darker than the predefined color.green. Finally, we draw a yellow oval. Here is the class that contains the main method. Notice that it adds an anonymous instance of the drawing class to the frame. All the remaining code should look familiar. Now let's run it. We see the square, circle, rectangle, and ovals drawn together with the two labels. One important point to notice is that in some cases the order in which we do the drawing matters. Because the yellow oval was drawn after the green rectangle, it appears on top of it. Whenever we wish to change what appears drawn on a panel, it is necessary to repaint it. What is important to understand is that the paint component method cannot be called directly because it requires a graphics object as its parameter, and the class that defines paint component does not have the necessary graphics object that is required. The window manager that is associated with all GUI programs has that object, so only the window manager can call that method directly. It automatically calls it on several occasions, when the panel is first displayed, and also whenever the frame that contains the panel is resized or moved. By calling a different method, repaint, which requires no parameters, we request that the window manager schedule a call to the paint component method. One final point is that paint component must always call the method it overrides. We already observed this issue in our previous example. In our previous example, the drawing panel was the only component that we added to the window. When we embed a drawing panel in a window that contains other components, it is necessary to provide some additional information to the layout manager. First, let's review what remains true from our previous example. It is still necessary for the drawing panel to extend the JPanel class, and it is still necessary that the class override the paint component method it would have inherited from JPanel. It is still the method that does the drawing. But what must now be done in addition is that it is now necessary to override the method getPreferredSize to specify the preferred size of the panel. It must return an object of the dimension class that contains the width and height desired for the panel. The method getMinimumSize can also be overridden, but that is not required. These methods are called by the layout manager to help it decide how much space to allocate to the panel. If we fail to include getPreferredSize, the panel will not appear. Although setSize is what is used to set the size of frames, calling setSize will not work for embedded panels. Next, let's examine a program that illustrates the use of a drawing panel that is embedded in a GUI that contains other components. First, we examine the class that defines the drawing panel. This class will draw a circle in the center of the panel. It contains methods that allow the color and diameter of the circle to be changed. These two constants define the preferred size of the panel and the initial diameter of the circle. As always, naming constants clarifies their purpose. These two instance variables are used to determine the color and diameter of the circle that is drawn. They can be modified by two of the instance methods. Next, let's examine the method that performs the drawing. The first step is to set the color to what is currently contained in the instance variable circle color. The call to fill oval is what draws the circle. Notice the calculations that are used to determine the XY coordinates of the upper left corner. The purpose of these calculations is to ensure that the circle is drawn in the center of the panel. Scrolling down to the other methods, the change color method changes the instance variable circle color to whatever color was passed to it as a parameter. Notice that it then calls repaint, which causes the window manager to call the paint component method. Similarly, change size changes the instance variable circle diameter to the value it is supplied. When we examine the remainder of this program, you will notice that this method is never called. We plan to reuse this class in a future example. That example will make use of this method. Finally, recall that it is necessary to provide a getPreferredSize method in this class. This method is called by the Layout Manager. Without this method, the drawing panel would not appear. Notice that it returns an object of type dimension that contains the preferred width and height of the panel. Next, we examine the class that defines the window that will contain the panel that draws a colorable circle. The user of this program is expected to specify the color by entering the RGB values in a text field and then clicking the Change Color button. These three instance variables define the three components that will be added to the window. They include the panel object, a text field, and a button. Next, we define a named lambda expression, Change Color, that will be called when the Change Color button is clicked. The first step is to extract the string that the user entered in the text field. Then the string is split into three strings by calling the split method, supplying a comma as a delimiter. Finally, the Change Color method of the colorable circle class is called, passing it the color. That color is constructed by calling the constructor of the color class that accepts the three RGB values. Each of them must be converted from a string to an integer by calling the parseInt method. Scrolling down to the remainder of the constructor, these statements set the Layout Manager and build the GUI. An anonymous label is added before the text field to clarify what is to be entered. The final step is to register the listener for button clicks by passing the named lambda expression Change Color to the Add Action Listener method. Okay, so let's run this program. Next, let's enter 128.0.128 as the RGB values in the text field, which should define a purple color. Next, let's click the Change Color button. Notice that the color of the circle has now been changed to purple.